Uh, so in this session, we will discuss Laurent series KTU problem, and this is lecture 2 of module 5. Okay, so first we will discuss these problems. These are previous year KTU problems. Okay, so first we will discuss this problem, and this is very important problem. Find all Taylor series and Laurent series of the function f of z equal to minus 2z plus 3 divided by z square minus 3z plus 2 with the center 0. Okay. In first question, mod z less than 1. That means center 0. Right? Mod z minus 0 less than 1. This is a circle with the center 0 and the radius 1. Okay. And second, we want to find the series expansion in annular region 1 less than mod z less than 2. So first what we will do is, uh, we have f of z is equal to minus 2z plus 3 divided by z square minus 3z plus 2. Okay. So this is equal to minus 2z plus 3 divided by this z square minus 3z plus 2 is z minus 1 into z minus 2. So, how to do Laurent series expansion? We will use non-Maclaurin series expansion like 1 by 1 plus z. We know that is 1 plus z square plus etc. 1 by 1 minus z, we know 1 minus z plus z square minus z cube plus etc. So this can be written as, we can use partial fraction, right? A by z minus 1 plus b by z minus 2. So which implies we can write 2z plus 3 divided by z minus 1 into z minus 2 is equal to, if you cross multiply this, you will get a into z minus 2 plus b into z minus 1 divided by z minus 1 into z minus 2. So which implies, so the numerator parts are equal, sorry, denominator part are equal. So the numerator must be equal because these both are equal. Right and left hand side are equal. So we can write minus 2z plus 3 is equal to a into z minus 2 plus b into z minus 1. So what we have to find? We have to find a and b. So these are the unknowns. Then we can write f of z in the form this, in this form. So for doing that, put if I put a z equal to 0 and I'm calling this equation number 1. If I put z equal to 1 in equation number 1 implies, if I put z equal to 1 here, then minus 2 plus 3 is equal to a into 1 minus 2 and b into 1 minus 1, that is plus 0. So which implies 1 equal to minus a, which implies a equal to minus 1. So we get a equal to minus 1. Now we will put z equal to 2 in equation number 1. If z equal to 2 in equation number 1 implies minus 2 into 2 minus 4 plus 3 is equal to, this becomes 0, right? Z equal to 2 plus b z minus 1 z into b into 2 minus 1 is b, which implies again b equal to minus. So therefore we can write minus 2z plus 3 divided by z minus 1 into z minus 2 is equal to a is minus 1, right? And b is also minus 1. So minus 1 by z minus 1 plus minus 1 by z minus 2. Now we want to find the Laurent series expansion or Laurent or Taylor series expansion of this equation number 2. So what we will do is we will find the Laurent series expansion of this and also this. Then if we find both Laurent series, then if you add both and we will add 1 and 2, we will get Laurent series expansion or Taylor series expansion of this. So for our first question, our region is given. Region is given as okay, region is given as region is given as okay, this is mod z less than 1. So that is our first question. So we want to find out Taylor or Laurent series in mod z less than 1. So what is mod z less than 1? It's a circle with the center 0 and radius 1. That means it's a disk. So this is a 0, 1. Mod z less. Now we will find Laurent series expansion of both and we will add. So minus 1 by 1 plus, sorry, minus 1 by z minus 1, this we can write as 1 by 1 minus z. And we know that this is valid when 1 plus z square plus etc. plus z power n plus etc. And this is valid when mod z less than 1. This is the Maclaurin series. Okay. Now similarly, what will be this? Minus 1 by z minus 2. This you can written as 1 by 2 minus z is equal to 1 by. Okay, we already know the expansion of this form. So I'm taking 2 outside. 1 minus z by 2. So this is 1 by 2 into 1 minus z by 2. So that is equal to 1 by 2 times. Okay, so we know this expansion when of the form this, right? So now instead of z, here z by 2. So what will be the expansion? 1 plus z by 2 plus, you replace z by 2. Z by 2 all square plus etc. Z by raised to n by 2 raised to n plus etc. So this will be the Laurent series expansion, Taylor series expansion. Therefore, so therefore, the Laurent, so here it is analytic. So the Taylor series expansion, Taylor or Laurent series expansion of minus 2 plus 3 divided by z square minus 3z plus 2 is equal to, what will be the Laurent series expansion? 1 this 1 plus z square plus etc. plus the Laurent series expansion of this 1 by 2, 1 plus z by 2 plus etc. So you can write it as sigma n equal to 0 to infinity z power n plus sigma n equal to 0 to infinity z power n by 2 power n plus 1. And you can combine both. Then you will get that. So this is valid when mod z less than 1. Okay, so here it is valid when mod z by 2 less than 1, which implies mod z less than 2. And this series is valid when mod z less than 1. So this is valid for all z less than 2. So obviously it is valid for all mod z less than 1. So the Taylor series expansion of this function when mod z less than 1 is this. Okay. So now we will move to any doubt. If you have any doubt, you can ask me. So we will move to the second part. It is an annular region mod z 1 less than mod z less than 2. So this is our annular region must be 1 and circle with the center 2. So this will be the annular region. Okay. So clearly f of z is analytic here, right? Because the point which f is not analytic is these 2 points, 1 and 2. Okay. So already we find that minus 2z plus 3 divided by z minus 1 into z minus 2. This is equal to minus 1 by z minus 1 plus minus 1 by z minus 2. This already we found. So here our z is in between 1 and 2. So already we have an expansion of this. Its expansion is minus 1 by z minus 2 is equal to 1 by 2 into 1 plus z by 2 plus z by 2 square plus etc. And this is valid when mod z less than 2. So here our mod z is always less than 2. So the first expansion is, you can write it. So we have minus 1 by z minus 2 is equal to 1 by 2 into 1 minus z by 2. This is equal to 1 by 2 plus 2 into 1 plus, 1 plus z by 2 plus z by 2 square plus etc. This is valid when mod z less than 2. So the series expansion of this is same as this. Now what about 1 by minus 1 by z minus 1? This you can written as 1 by 1 minus z. But our expansion, this expansion is valid only when mod z less than 1. That means for any z such that mod z less than 1. But here, so here our mod z is greater than 1, right? So here mod z is greater than 1 and less than 2. So already we have mod z greater than 1, which implies I can write 1 by mod z is less than 1. So instead of z, here if we have 1 by z, then we can use the expansion. So what we will do is, I'm taking outside z into 1 by z minus 1. Okay. So I'm taking minus 1 outside. So minus 1 by z into 1 by 1 minus 1 by z. Okay. So here we know that if mod z greater than 1, which implies 1 by mod z is less than 1. So how you can write this expansion? Minus 1 by z. Now we will use this expansion. 1 by 1 minus z is 1 plus z square plus etc. Here instead of z, we have 1 by z. So this is 1 plus 1 by z plus 1 by z square plus etc. So this is valid when mod 1 by z less than 1, which implies mod z greater than. So so for so for 1 less than mod z less than 2, we have minus 2z plus 3 divided by z minus 1 into z minus 2 is equal to, first we will use this is equal to, we have minus 1 by z, this expansion 1 plus 1 by z plus 1 by z all square plus etc. plus the second expansion is same as this. So this expansion, that is 1 by 2 times 1 plus z by 2 plus z by 2 square plus etc. And this is valid when 1 less than mod z less than 2. So this is valid when. So this will be the all Taylor series and Laurent series. So in the first equation, ഫസ്റ്റ് പാർട്ടിൽ എന്താണ് സംഭവിക്കുന്നത്? നമ്മുടെ ഈ എക്സ്പാൻഷനിൽ, so this is the Taylor series expansion. This expansion there is no 1 by z form. Denominatorly z ഇല്ല. Okay, both every power of z is positive, 1 2 etc. So therefore there is no principal part, only Taylor series part is there. So this is the Taylor series. One that polynomial, that rational function has a Taylor series expansion when mod z less than 1, but in when 1 less than mod z less than 2, we have here there is denominator has power negative, sorry, here z has negative powers, right? So this is the Laurent series expansion. Okay, so this is very simple. So what we have to do is we have to convert it into, make it into rational, the form that we know. So this is always we can use partial fraction. Okay. So if you have any doubt, you can ask me. Now we will do this second question. This is KT 2019 question. Last. Okay, so we will do this form. Okay, so what is the question? Find the Laurent series expansion of 1 by z minus 1 into z minus 2. So here there is three questions. One is 1 less than mod z less than 2, and then mod z greater than 2. These are the region. And here 1 z minus 1, 0 less than mod z minus 1 less than 1. So first two case our center is 0. So because z minus 1 less than, so here center is 0, here also center 0, and here center 1. So first what we will do is, so we have given f of z is equal to 1 by z minus 1 into z minus 2. So this equation, we will use partial fraction a by z minus 1 plus b by z minus 2, which implies 1 equal to a into z minus 2 plus b into z minus 1. Okay, so this is our equation. Now we will find a and b. So what we will do is put z equal to 1 in equation number 1. So I am calling this equation number 1. So therefore 1 equal to z equal to 1 means a into 1 minus 2, which implies a equal to minus 1. So minus a equal to 1, therefore a equal to minus 1. Now similarly put z equal to 2, then in equation number 2, sorry 1, then 1 equal to b. So this is b equal to 1. So this equation can be written as, which implies 1 by z minus 1 into z minus 2 is equal to a minus 1 by z minus 1 plus 1 by z minus 2. So what is our first region? So sometimes we have given the region 1 less than 1 less than mod z less than 2. So that is our first region. So, 1 less than mod z less than 2. So this is equal to 1. Two. So this is our region. So here the function is analytic, right? Only the point of singularity is these 2 points. So now what we will have, so I'm taking, so the series expansion of this is sum of the series expansion of these 2. So first minus 1 by z minus 1 you can written as 1 by 1 minus z. So now here our mode. So this has a series 1 by 1 minus z has a series expansion 1 plus z square plus etc. when mod z greater than 1. Sorry, less than 1. But here mod z is always greater than 1, which implies 1 by mod z less than 1. So what we will do is we will take z outside. I am taking minus z outside. So this will become minus 1 by z plus 1. So this is equal to 1 minus z 1 minus z into 1 minus 1 by z. So clearly for here mod z is mod 1 by z is less than 1. So we can use series expansion. Minus 1 by z into 1 by 1 minus 1 by z. So this is equal to minus 1 by z into 1 plus 1 by z plus 1 by z square plus etc. Okay, any doubt? So this is mod, this is valid when mod 1 by z less than 1, which implies mod z greater than 1. So if you take reciprocal, so here it is valid, right? Because our region is, the region is mod z greater than 1 and in between 1 and 2. So the second region is 1 by z minus 2. So this can be written as 1 by, if you take 2 outside, minus 2 outside, 1 minus z by 2. So this is equal to minus 1 by 2 into 1 by 1 minus z by 2. So if you expand this, this is valid when mod 1 by z less than 1, which implies mod z less than 2, right? So, so this is equal to minus 1 by 2 into, if you expand this, 1 plus z by 2 plus z by 2 square plus etc. So this is valid when mod z by 2 less than 1, which implies mod z less than 2. So this expansion is valid whenever mod z less than 2, and this expansion is valid for all mod z greater than 1. So therefore our question is, therefore we will use sum of these two. Therefore 1 by, therefore for 1 less than mod z less than 2, we have Laurent series expansion of Laurent series expansion of 1 by z minus 1 into z minus 2 is equal to, so this is 1 minus z minus 1 plus 1 by z minus 2, uh, minus 1 by z minus plus 1 by z minus 2. So here we can use the expansion. So for the first case, this is, what is the series expansion? 1 minus 1 by z minus 1 by z into 1 plus 1 by z plus 1 by z square plus etc. plus, and what will be the second series? So the series, Laurent series expansion is sum of both series expansion. So that is equal to this. So this is minus 1 by 2, 1 plus z by 2 plus z by 2 whole square plus etc. So these are the series expansion. One thing you can do is you can add and write it as a one series. ഒരു series ആയിട്ട് എഴുതാൻ പറ്റും. Okay. So if you write this is valid when 1 less than mod z less than. Okay. Now we will use the third region. So this is very important. Third region is 0 less than 1 minus mod z minus 1 less than 1. So here center is different, right? So this is so our region is 0 less than mod z minus 1 less than 1. So here the center is 1, right? So we want to expand it into the form z minus 1 all raised to n. So this is our region. Z is 1. This one. Circle with the center 1 and radius 1. So this is mod z minus 1 equal to 1. This circle. So this region we have here. And there is no center. So this annular region. The remaining portion is our. So our f of z is equal to 1 by z minus 1 into z plus z minus 2. This is minus 1 by z minus 1 plus 1 by z minus 2. So we want the expansion in the form z minus 1. So listen here. Here this term is already in z minus 1 form, right? So this is z minus 1 all raised to minus 1. So we doesn't want to change this, and we have to change this in that form. So this is equal to minus 1 z minus 1. This is already, we can keep it same as that, plus 1 by, now we want to change it in the form z minus 1. So what we will do is, so we can write it as z minus 1 minus 1, right? Z minus 2 is z minus 1 minus 1. So this is z minus 1 plus 1 by, I'm taking minus 1 outside. So this is equal to 1 minus z minus 1, right? So this is equal to minus 1 by 1 into 1 by 1 minus z minus 1. So why we have taking like this? Because here our center is 1. So we want to expand it of the form z minus 1. So this is equal to, and also this is less than 1. So this is minus of, if you expand, instead of z we can take z minus 1. So 1 plus z minus 1 plus z minus 1 all square plus z minus 1 all cube plus etc. And this is valid when mod z minus 1 less than 1. So therefore the Laurent series expansion of 1 by z minus 1 into z minus 2 on the region 0 less than mod z less than mod z minus 1 less than 1 is 1 by z minus 1 into z minus 2 is equal to, you can write this form. So there is 1 by z minus 1 is also equal to 1 by z minus. So this is equal to 1 by z minus 1 minus of 1 plus z minus 1 plus z minus 1 all square plus etc. So this is the Laurent series expansion that is valid when 0 less than or less than 1. So here the principal part is this. This is our principal part, only one term, and this is the Taylor series part. Okay. So this is the problem. So we done two problems uh, regarding to this.